hydrogen fuel cells. I'll test the main advantages of this innovation, future prospects, and the principle of its work. So let's get started. Hydrogen fuel cell generates power quickly and efficiently. Hydrogen fuel cell is electrochemical energy conversion device. It converts two chemicals, oxygen and hydrogen, into water. And while doing so, it produces electricity. With hydrogen fuel cells, these two chemicals constantly flow into the cell, so it never goes dead. In other words, as long as there is a flow of chemicals into the cell, electricity flows out of the cell. Now let's see how it works. Hydrogen fuel cell vehicle is generated by hydrogen fuel cell stack. It's a group of individual fuel cells. Fuel cell stack generates power as long as fuel is available, similar to internal combustion engine. Electricity generated by hydrogen fuel cell stack generates power, generates electric motor that propels the vehicle. So each fuel cell stack, as you can see on the slide, consists of anode, this part, cathode, and proton exchange membrane sandwiched in between. Hydrogen from the tank on board enters the anode side. Oxygen pulled from the air enters the cathode side. As the hydrogen molecule encounters the membrane, the catalysis forces it to split into proton and electron. So the proton goes through the membrane and electron enters the external circuit, delivering current to the motor and other vehicle components. At the cathode side, proton and electron meets again. Proton and electron join again and then combine with oxygen to form the only vehicle's tailpipe emission water. So here on the next slide, you can see the process of generating electricity with hydrogen and oxygen and all the three steps that I've just mentioned. Now let's list the main fuel cell's advantages, and they are the following. It's energy diversification. Hydrogen can be made using a wide variety of primary energy sources. It's zero emission of harmful substances when driving. It can be used as a power supply because it can double as a high-capacity power supply during emergencies. About the performance, a cruising range on par with a conventional gasoline-fueled vehicle. It can be refueled in about 3 minutes. And last but not the least, it's fun to drive, smooth and quiet, with excellent low and mid-range acceleration characteristic of motor-driven cars. As you can see, hydrogen fuel cell may have a big future in automobile industry, but I'm personally convinced that there is no potential for such innovation. Firstly, building hydrogen infrastructure would be an estimated $200 trillion. Compare this to the cost of a smart electric grid, which varies from $338 billion to $476 billion, and that would import from $1.4 trillion to $2 trillion in economic benefit. The second fundamental problem with fuel cells is fuel itself, because hydrogen is not a source of energy, it's a store of energy, much like a battery. And there is no pure hydrogen. It can only be obtained through electrolysis or through natural carbon processing. At any rate, both ways require burning of coal, oil, uranium, gas. And so while calculating the work efficiency of such engine, we should consider the whole chain. And that is the production of electricity at a power plant, the power transmission, then hydrogen production and hydrogen transportation. And the work efficiency of such engine is going to be lower than the work efficiency of any internal combustion or diesel engine. Moreover, hydrogen fuel cells consume more fuel, they are uneconomic, and they give off more pollution effect. Because theoretically such engine gives off only water. But in the real world, it's impossible to achieve such perfect combustion. So the carbon oxides form, hydro oxides also form, and they lead to metal corrosion. They form alkali, which are quite harmful for the environment. So there are also nitrogen compounds, hydrogen peroxide, and etc. While the hydrogen, whose groups are individual, also destroys the ozone layer. Now, water steam as mass emission is also a serious problem because it can lead to various unpredictable climate changes. Like carbon dioxide, it's a greenhouse gas which also increases metal corrosion, and that can lead to various man-made disasters. It increases fog density and road slippery, and that can lead to more traffic accidents. And then, despite the fact that the maintenance of fuel cell is quite simple because there are few moving parts in the system, still compared to internal combustion or diesel engine, it still has two main disadvantages, and they are high cost and low power returns. Then, besides that, according to various estimates, the total work efficiency of all internal combustion and diesel engines still exceeds the work efficiency of electric power stations. And the latter, as we all know, tend to break from time to time, and it takes from 3 to 5 years to fix one electric station. That makes it obvious for us that we cannot rely on electric power in the automobile industry, at least in the nearest century. Then comes the safety problem. Hydrogen mixed with air, much like propane or gasoline vapors, form a volatile mix. And unlike propane, hydrogen cannot be stored in containers because its molecules are so small it can easily diffuse to metal. Of course, there are other ways of store hydrogen, and they are metal hydrides, the one you can see on the slide. It's a special container with alloys that absorb hydrogen into its crystal lattice and give it back when heated. So this method has high storage density packing of fuel, but the problem is that the container itself can be heated not only from the heater, but also from the sun, from the engine, or from whatever other reason, and that can lead to hydrogen leakage and then to hydrogen explosion, so it's quite dangerous. Of course, everything can be foreseen and managed, special coating, thermostats, leak detectors, ventilation, and etc. But then again, such vehicles gonna cost like spacecraft, and nobody would buy it. In conclusion, summarizing everything that I've just said, when we come to the conclusion that hydrogen fuel cells engine have its perspective and future in the fields where maximum power and speed is the top priority, regardless of cost and environmental issue it may have. But the wide use of it in automobile industry is absolutely utopic because it's unsafe, expensive, it's environmentally unfriendly. It cannot be required with it cannot be provided with the required amount of hydrogen. It has low power returns. Fortunately, currently there are several really promising alternative technologies that don't fully solve economic, energy, and environmental issues, but that can change the whole situation in general. And they're the following: it's biofuels, methane, ethanol, rapeseed oil, coal, hybrids, and batteries. So, thank you everybody for your attention.
So we have the way out, yeah? We have the way out.
Yes, we have the way out.
Why have you chosen this topic for the conference?
Because it's really, it's of a big importance now because we have several environmental issues. We keep using gasoline and oil, and as far as I know, all the oil that we have is going to last for the next 15 years. For example, if we take coal and try to put it in the automobile industry, the coal storage that we have is going to last for the next 500 years, so it's a big difference. And carbon dioxide emissions is also a serious problem. So this topic is important, I think.
The topic is topical.
Topical, yeah.
Yes, may I ask you a question?
Sure.
As far as I understand, the message of your report is to dismiss hydrogen installed
In automobile industry.
in automobile.
Yes.
But and you just showed us at the end of the presentation that biofuels, coal, gas is more attractive, I suppose.
It has, it's not more attractive, but I think in terms of money, financial part, it's more promising than hydrogen fuel cell, because hydrogen itself is also biofuel. I agree with you. It's like a part of biofuels, but it's too expensive and unsafe and everything that I've just mentioned. But compared to biofuels, which doesn't require such a big rebuilding of infrastructure, because right now a lot of cars run on methanol or ethanol, and you don't need to rebuild your car. You don't need a new engine type or something else to use this kind of fuel.
Well, the point of my question is, if you criticize hydrogen fuels, then I should put against hydrogen and, so, for example, biofuels or gas fuels. And as far as I understand, you are an economist. Well, really, would be economist.
No.
No?
No.
Yes. Well, in this, it leads me to a question. Do you know some government programs in the USA, Great Britain, Germany, which support hydrogen fuel researchers?
Yes, I know. Especially USA, they run a lot of programs that sponsoring every year something connected with hydrogen fuel cells. And I know that, for example, Hyundai i35, they released this car with a hydrogen tank at the rear part for 3 years to see how it's going to work. And I don't know how many years ago they started doing this, but the point is that they don't have infrastructure yet. And I don't know how people are going to use this car. I don't know how they're going to put hydrogen into it. And I personally think that there is no future.
Okay, if we, I suppose, run out of oil in nearest 50 years, as supposed by economists and futurologists, you know, what kind of vehicle would you prefer to drive?
I think it all depends on the country you live in. Because, for example, in our country, we cannot use batteries, electromotors, because they're going to run down in winter. For example, I don't know, we don't have batteries that are going to work in Siberia. We are working on these batteries, but we don't have it right now. For our country, I would prefer hybrids, but still, hybrids like that runs not on internal combustion engine with electric motor, but internal combustion engine that runs not on the oil, but on the biofuels.
Of course, and well, as an engineer, which kind of car would you like to develop?
Honestly speaking, I would like to develop, to start with hybrids, because for me it's like a dual clutch transmission. It's not a mechanical and it's not an automatic. It's something in between. It's like a temporary way. But then to start working on alternative fuel sources like biofuels, and to construct, or maybe I also interested in engines. They called flex fuel engines. They can run not only on the oil but also on the ethanol, pure ethanol. It's like 85% of ethanol and other.
On whiskey.
Oh yeah. But I heard that scientists right now are working on a ways to make from the like rivers and other sources of human and animals.
Okay. You see, Anastasia, only the student of the second grade. She has a lot ahead. Well, that's a great future, I think so. Such a way. Good English, well, a lot of ideas. You will be a real engineer in the future. I hope. That's why she's only a student, and she knows so much.
What year student are you?
Yeah.
What year student are you? Oh, I see. So perfect.
Thank you.
Thank you twice. You she's a lady engineer.
Yeah. Full of ideas.